Peter, what happened? You had started screen sharing. Okay. So you can begin telling us what you did.
This was the first number. So I've forgotten the name of this method, but we multiply the number that's above by that below, and so that we can make these first numbers the same, so that we may subtract them and remain with one unknown.
Okay.
So when we do that, we remain with 2y equals -1, divide 2 on both sides, and y is 0.5. Then we substitute it into any of our equations.
Yes.
We do that, becomes x plus 2 times 0.5, which is 1, equals 3. And our answer is 2, because we take the 1 onto the other side and subtract it from 3.
Okay.
Is that okay?
Yes, let us try and substitute and see if so 3 times 2, that is 6. Then 4 times 0.5 is 2, so 4 plus 6 plus 2 is 8. Then when we come to this second method, okay, second equation, x is 2 plus 2 times 0.5 is 1 plus 3. So the answers are correct.
And for the second number, I used matrix form.
Hey, also no matrix. Okay.
So we form matrices that those that are part of the x unknowns alone and those of the y unknowns alone. Then the x and y unknowns alone equaling to what had been given to us here.
Yes.
Then we get the figures in the leading diagonal, multiply them, and subtract those in the minor diagonal to get the determinant here.
Yes.
And get the inverse, so that we can get the inverse.
Okay.
And we also do it on the other side, just as we can see here. Then we expand through. When we're using this method, we always know that we have to end up with a identity matrix.
Yes, which is a 2 by 2.
Yes, which is this here. So when we multiply the identity matrix by this matrix, to give us x will be equaling to 1 and 11 out of 26, and y will be equaling to -1 out of 26.
Okay. So if we can just explain a bit more for our other friend to get it better.
Okay, so from this point, we multiply this determinant through everything here in this matrix here.
Yes.
When we do that, -1 out of 26 times -4, we get 2 out of 13. Then we do the same for -3. We get 3 out of 26. The same for -2. We get 1 out of 13. Then when you multiply it by 5, we get -5 out of 26. Then we also do the same for this, which will technically be the same. Then multiply this whole matrix by this one, and we get 2 out of 13 times 5, which gives us 10 out of 13. Then 3 out of 26 times 2, which gives us 3 out of 13. Then the bottom ones, 1 out of 13 times 5, give us 5 out of 13, and negative 5 out of 26 multiplied by 2, get negative 5 out of 13. Then 2 out of 13 times 3, get 6 out of 13, and 3 out of 26 times negative 4 will be negative 6 out of 13. 1 out of 13 times 3 gives 3 out of 13. Negative 5 out of 26 times negative 4 gives 10 out of 13. We also come this one, multiply through, and we always know that 2 by 2 matrix should come before the 1 by 1 in order for them to multiply successfully.
Yes.
So multiply 2 out of 13 by 7 gives us 1, 4, 1 and 1 out of 13. 3 out of 26 multiplied by 3, get 9 out of 26. Then 1 out of 13 times 7 gets 7 out of 13, and negative 5 out of 26 multiplied by 3 gives us negative 15 out of 26. So when we work out here, this becomes 13 out of 13, which is 1. Then this is a 0, as you can see here. This is also a 0, and this is still 13 out of 13, which is 1. When we add these, here we get 111 out of 26, and this becomes negative 1 out of 26. So when we multiply the identity matrix by this one that contains x and y, we'll see that 1 times x is x, 0 times y is 0. So x will be equal to 111 out of 26, and y will automatically be negative 1 out of 26.
Okay.
Then the third number. The third one, I use substitution.
Okay.
So we first take this one this way in order to make the simultaneous equation easier to work out, and becomes x plus 2y equals to negative 1. So in this case, using this second equation, make x the subject, and becomes, we take 2y to the other side, and becomes negative 2y minus 1. So we substitute this into this x here, and it will become 2 times the negative 2y minus 1 minus y up here equals to 2. So this 2 multiplies the 2y, it becomes negative 4y, and the 2 also multiplies negative 1 and becomes negative 2 minus y equals to 12. So we take this 2 to the other side, and becomes a positive, a plus 2. So 12 plus 2 is 14, and negative 4y minus y is negative 5y. Divide negative 5 on both sides, y becomes negative 2.8. So since we have found y here, we go back and substitute it up here in this equation. So x plus 2 into negative 2.8 equals to negative 1. 2 times negative 2.8 is negative 5.6. Should have been a minus. So when you take it the other side, it becomes x equals to negative 1 plus 5.6, which is 4.6.
Okay, thank you very much. I hope everything is okay to my other friend, Ngi. Is it okay for the simultaneous equations? I see you have been typing in the chat. You can type. Okay. So briefly, that is what we look to like what we is involved in simultaneous equations. Did all of us watch the videos on the site in this unit of simultaneous equations? Peter, have you finished watching the videos?
Yes, please.
Did you watch the videos in the unit simultaneous equations?
Yes, that was some time back, so I may not recall exactly what had been said.
Yeah. But the good chances that you can now do what sort of those equations using these three different methods so far.
Just to be clear, what's the name for the first method I used? I'm not sure of it.
There is elimination method.
Elimination method.
Yes. So that is where you multiply by a certain constant and you remove either the x or the y, and then after you divide. You subtract and divide and get the answer of x or y. Yes, Singe, did you finish watching the videos? You can type in the chat. Okay, Peter, there is some work I had sent you. Did you see it?
I think this was the work that you sent via I think that the WhatsApp group.
Yes, there is another one I sent in this on the site.
And then I'll have to check.
You haven't checked there. You have to check there every day. Okay. So let us go to the site and do something briefly there. Okay, as we wait for this page to load. Ilanya, you are welcome. Did you do the work I sent on the group? Ilanya. Jackie, you are welcome.
Thank you, teacher.
Yes. Did you do the work?
Teacher, I haven't received it.
In the group, on the WhatsApp group?
No, I've just joined yesterday.
Sure, as if I'll send it again.
All right.
Okay. So meaning you have missed is covering simultaneous equations. Had you covered them at school?
Yes.
Okay, that is good then. How about subject of the formula? Did we cover it with you? In the other first 2 weeks?
Teacher, may I stop on functions?
You stopped on functions. Okay, so you should get a day and then we discuss the what? And the subject of the formula. So right now, we finished this for some of us, even the composite functions, I think for all of us. So we should go in there and check whether the assignments, we check and do the assignments.
Excuse me.
Yes.
In the unit for formula, could you first go to the assignment? There's something that
I'm going to, I was going to
yes,
upload.
in the unit for formula, it's assignment.
Yes, I saw it.
Right.
And I think that because the message is in it, but I sent you some work that is supposed to be there.
The first number. How are
Yes,
you
this one
supposed
here.
to? Yes, that metoba.
There's something that is missing. I think some of the formulas I think disappeared because as you see,
So you're breaking.
A was supposed to be called something, then this formula here. So there is some other message which I sent you. Maybe let me pass it to you. Then they send you some add this, all of you can be Yes, my internet had gone off, but I think it is now stable. Can you hear me? Okay. So I was trying to show Peter Emma the message that I'd sent him. So maybe let me first. Do all of us know how to send messages on the site?
Yes, teacher.
Yes.
Okay, that is good then. So I'm going to send a message to everyone there of the work that I sent to Peter. So let me go straight to what we are going to cover. So for simultaneous equations, those who haven't yet covered them, please you get in touch with me and we see how best to cover them. Okay. So for formula, composite functions, and then simultaneous equations. So if you have not done them, please let us get in touch and then we cover them. So you can propose the time when you're free and then we go through them. Then I'm going to be sending work, if possible, on a daily basis. So make sure you also do that work, if possible, still on daily what? On daily basis. Is that okay?
Yes, teacher.
Yes, teacher.
Okay. How many of us had covered probability?
Me.
Let's see. Jackie?
Teacher, I haven't.
You haven't. So hope you had.
Yes, teacher.
Okay. Your hand is up. It seems you had something to say.
I was just answering. You were asking those people who covered probability.
Okay, so since you covered probability, can you tell us what is in probability? Hope. Okay, who can read for us these first statements here? All of us have decided to keep quiet. So is my network still bad? Because I didn't hear Peter very well. He was breaking.
Me too, I didn't hear him.
Okay. Okay, so let us briefly talk about probability. We introduce it, and then you'll get time and go to this site and you watch the videos that are in there. So we are saying probability is a numerical value given to chance that a certain event will occur. So it is chance. So most times we play games and those games involve chance. How many of you have ever tossed coins or a coin with friends? How many? Yes, Peter. You have ever done?
Yes.
Okay. So how is it played?
Learn.
How do you toss it? And when you toss it, what happens? What do you expect at the end?
When you toss it, you might either land on the side of the head or the tail. For example, if it's 100 shilling side with so that's how.
Okay, much as we didn't hear some of the words you were breaking, but when you play, when you toss a coin, you expect either to get a head or a tail. So it has two sides, one that has a head and the other one that has a tail. So when you toss it, it can either show a head or a tail. So that process, when you are doing that process, what you expect. So if you get a head, then and you give it a value, a numerical value, that a head will appear. So the chances of a head appearing are 1 out of 2 because the coin has only two sides. So you expect it to either give you a head or a tail. So we give it a numerical value of a half. So the probability of getting a head is a half, and then the probability of getting a tail is also a half because they are two. So here there's something which was missed. Probability that an event occurs is equal to, so it should be number of event divided by number of the sample space, or the total number of the total outcomes. Okay, so maybe let me share something else. So probability of E, so E represents the event, is equal to number of E. Then we divide this by number of S. So S represents the sample space. Yes. So what is a sample space? Okay, like the meaning of the sample space. So we are saying in tossing a coin, we expect to get a head or a head and tail. So this, we call it as the sample space, a set of all possible outcomes. So it's the one we call a sample space. So here, the number of sample space will be equal to, so what will be the number of the sample space? Number of sample space, 2. Okay. So it will be 2. Then if we are interested in getting probability of a head, okay? So now our event becomes what is a head, okay? So the event is what we are interested in, the desirable outcome. So the event is the desirable what? Outcome. So what we are interested in. So E, which is the event, will be equal to a head, for example, if our interest is getting what? A head. Then now we would say probability of getting a head is the same as number of head, which is equal to 1. Then we divide this by 2. And that is how we get the probability of a head equaling to a half. So still, if we want probability of a tail, and will also be the tail, the desirable outcome will be what? A 1. And then the sample space will be what? A 2. So the probability will still be the same as a half. Okay, is that okay?
Yes.
Yes, teacher.
Okay. So suppose we now want to throw 2 coins. What will be the sample space if we are throwing 2 coins?
4.
4 is the number.
Like, teacher, maybe we can draw.
Okay, so we draw. So we have head here and tail. So we call this one our first what? Our first coin. Then we have another head here and another what? Tail for the second what? Coin. Then we now fill this table here. So here is head and here is head. So we shall have head.
Head.
Head what? Head.
Head.
What shall we
Head,
have
tail.
here?
Head, tail.
Head, tail. And then here?
Tail, head.
Tail, head. And then tail what?
Tail.
Tail. So what will be our sample space?
It will be HHHTTHT.
So HH, head, tail, tail, head, and then tail and tail. Okay, and then number of sample space will be equal to, what will be the number of the sample space? 4. So this will be 4. Okay. Now, if we wanted to get the probability of only getting heads, okay? Probability of getting what? Heads. What would that be equal to?
3.
3. Of getting all of them being heads, you toss, the first one is a head, you toss again, the second one is a head. Have you seen where I've circled?
Yes, it is 2/4.
Okay. 2/4. Where is the 2 coming from? This is 1 where we get heads. Then we divide this by 4. So it will be 1/4. Okay. Then probability of getting a head and tail.
2/4.
Head and tail.
4.
Head and tail
Yes.
is this head and this. So there will be
Head and tail. 2.
Yeah, 2. So this will be equal to 2 divided by 4.
4.
Which is the same as
2.
1/2.
2, yeah. Yes, same as 1/2. Okay. So this is just a brief introduction about what? About probability. And the probability is we said by formula is number of S divided by number of events divided by number of the sample space. Yes, Jackie? Yes.
Teacher, it's a must when you're getting probability, you need to get a fraction as your answer.
Yes. Yes, it can be a fraction. You can leave this as 0.5. Okay. So maybe probability lies between 0 and 1. So our values should be between these two. Okay.
All right.
So when you get 0, it implies that something will not occur. Okay, will not occur. When you get 1, then it implies that something is, or that event is certain to do what? To occur. And then all the other values will lie in between here. So that is why we are getting what? We are getting fractions. Is that okay?
Yes.
Yes.
Okay. Yes, then my friend who types in the chat, is it okay? Type, please type there so that I know whether it is okay or not. So let us briefly go back to our notes. Yeah, it is okay for him as well. So we haven't done the one of when 3 coins are tossed, but when the 3 coins are tossed, we shall come to it when we go to tree diagrams and we draw a tree diagram. Then there we can be able to illustrate how we get a sample space of throwing 3 coins. Okay. Then we also have a possibility of throwing a die, and a die is numbered 1 up to what? What is a die numbered up to?
So 6.
6.
1 up to 6.
Okay, so it has sides 1 up to 6, and when you toss it, each side shows, so you are able to take that side. There are some games which I normally see people playing, but me, I've never played them, but they are mathematical. So with that die, so you come and watch this video here. It is talking about sample space, events, outcomes, and experiments. Okay. Then after that, we shall go to the relationship between set theory and the probability. How many of us had covered sets in senior? How many of us have covered sets?
Which I did.
You did, Peter did. Okay. So watch this video, then I'm going to send you some work about sets such that we remember them, and then after we are able to continue with our probability. So meanwhile, those of you who did the work of what I sent in the group can send them in this platform, then I'll be able to mark the work. Okay. Any questions?
No, not teacher.
Teacher,
Yes.
how do you submit in through the WhatsApp group or what?
Okay, let me show you briefly here. So when you open and you access this page here, okay?
Yes.
Then you come to messages, okay? Then you'll see this side is for messages that come in to your side. Then these ones are for sending, okay? So you come and let me see, inbox. You click here on a new message, okay?
Yes.
Then it brings this recipient. So you search for your teacher's name, okay? You know my name? Yes, then you put there the subject, like what you are sending, maybe if it is work, okay?
Yeah.
Then you type some brief message there, okay? Then after that you come here. Are you seeing these 3? So this one is for if you want to attach a document, okay?
Yeah.
This one is for a video. then this one is for a photo or an image. Okay. So if you have typed your work, you come and click on this one. Then it brings upload what? Upload file. Then you click on upload file. So it will take you in your computer stuff where that work is. Then you can click on the work. Then the work will be able to come here.
Okay.
Then after that, you send the message. So I will be able to receive the message and then mark your work and also respond to it.
So you can do the sendings when we are in class.
No, not specifically when we are in class. You can, when I send the work, you can do it. Then after doing it, you send it here. I mark it. Then I add some comments there. Okay. Because all of us are not going to be having classes at the same time. Okay.
Okay.
So for you, anytime when you feel there is something you need to cover, you just let me know on the WhatsApp group. Maybe you can send me a private message. Then we arrange and have help in an area where you need to be helped.
Okay.
Okay.
Thank you, teacher.
You're welcome. Bye.
Our lesson.
You're welcome. You're welcome. Okay, we shall meet again.
Okay, bye.
Bye.